In this video, we are going to go over a postulate and two theorems involving triangle similarity. So if you remember how we showed that triangles were congruent, there are also ways to show that triangles are similar. So let's look at our first postulate, the angle-angle similarity postulate. So the angle-angle similarity postulate, P20, says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So since this angle is congruent to this angle, and this angle is congruent to this angle, then these two triangles are similar. Now let's dive into our theorems. The side-side-side similarity theorem, or SSS theorem for short, T39 says that if three sides of one triangle are proportional to three corresponding sides of a second triangle, then the triangles are similar. So if these first sides are proportional to the second sides, which are proportional to the corresponding third sides, then the triangles are similar. The side-angle-side SAS Similarity theorem, T40 in our case, says that if two sides of one triangle are proportional to two sides of another triangle, this side is proportional with those sides, and their included angles are congruent. So the included angle is the angle that is between the sides that are all proportional. If we're using this side and this side proportional to this side and this side, then the included angles would be right there. And if those included angles are congruent, then the triangles are similar. Let's go ahead and prove one of these theorems. Let's do T39, the side-side-side similarity theorem. This theorem gives us that all the sides are proportional, so we're going to start with that. So we're going to start with what's given. And it was that the sides of one triangle are proportional to the sides of another triangle. So we have AB over DE is equal to BC over EF, which is equal to AC over DF. We're going to construct a point on the segment AB, let's name that point X, such that the segment AX is going to be congruent to DE, and we're going to make a point Y such that the line XY is parallel with BC. So we constructed XY such that X is on AB and Y is on AC, so that AX is congruent to DE and segment XY is parallel to segment BC. And that's what we constructed, so you can say constructed or given. Now, since AX is congruent to segment DE, we can say that those measures are equal. And that's by the definition of congruent segments. AX equals DE. Let's use substitution and substitute AX in for the proportions in number 1. So by substitution, we now have AB over AX is equal to BC over EF, which equals AC over DF. We just substituted AX in for DE. Remember also that when we constructed XY, we made it parallel to BC. So since these are parallel, we can say that angle B is congruent to angle X, and angle Y is congruent to angle C. And that's by the corresponding angles postulate, which was P12. P12 simply said that if two lines are parallel and the transversal intersects them, then the corresponding angles are congruent. X and B are corresponding angles, and C and Y are corresponding angles. Since we have that these two angles and these two angles are congruent, we can use the postulate that we went over earlier in this lesson, the angle-angle similarity postulate, which says that if two angles of one triangle are congruent to two angles of another triangle, then those triangles are similar. So we're going to have that triangle ABC is similar to triangle AXY. And if two triangles are similar, then we know that their corresponding sides are proportional. And that's by the definition of similar polygons. AB over AX is equal to BC over XY, which is equal to AC over AY. AB over AX equal to BC over XY, which is equal to AC over AY. Now looking at our proof, we have three different proportions. So we're going to be able to use substitution and say that BC over XY is also equal to BC over EF, because this AB over AX and this AB over AX are equal to both of them. Same with AC over AY and AC over DF. So BC over EF equals BC over XY, and AC over DF equals AC over AY. Looking at this, the numerators are the same, and the numerators are the same again. So we can use multiplication and division properties to say that EF is equal to XY and DF is equal to AY. And since they're equal in measure, they're also congruent by the definition of congruent segments. We have segment EF is congruent to segment XY, and segment DF is congruent to segment AY. So looking back up at our picture, EF is congruent to XY, DF is congruent to AY, and we already had that AX was congruent to DE. If you remember the side-side-side congruence postulate, which was P17, says that if the sides of one triangle are congruent to the corresponding sides of another triangle, so all three sides, then the triangles are congruent. So if triangle AXY is congruent to triangle DEF, we know that the corresponding parts of those congruent triangles are congruent. Looking at our picture again, we can say that this angle A is congruent to this angle D, and we can also say that angle E is congruent to angle X, because triangle AXY is congruent to triangle DEF. Angle X was also congruent to angle B, and that was by the corresponding angles postulate. So by the transitive property, we can say that angle B is congruent to angle E. And this is because of the transitive property in the angle congruence theorem. We have that angle B is now congruent to angle E, and we already had that angle A and angle D were congruent, so we're going to go back to the postulate we learned in the beginning of this lesson, the angle-angle similarity postulate, which says that if two angles of one triangle are congruent to corresponding angles on a second triangle, then the triangles are similar. And now we have proved what we set out to prove. That triangle ABC is similar to triangle DEF, given that the sides are proportional.